Let's talk about something you probably do every single day without even thinking about it, pushing the power button on your computer. It feels almost like magic, right? One second it's a lifeless box, the next it's ready to go. But what's actually happening in there? It's a surprisingly cool and detailed dance that brings your machine to life.
No, seriously, have you ever really thought about it? You hit one button and this hunk of metal and plastic just wakes up and connects you to pretty much everything. How in the world does it go from completely off to totally on? Well, that's exactly what we're about to unpack. So, here's the game plan. First, we'll look at the computer's morning routine. Then, we'll see how it does a quick health check. After that, we go on a hunt for its brain, aka the operating system. We're also going to cover the difference between a cold start and a quick restart, and even what happens when a computer has more than one brain to pick from. All right, let's get right into it. Think of your computer as being deep asleep. When you hit that power button, you're not just flipping a switch, you are kicking off this really elegant and complex wake-up call. And this whole process has a name.
It's called booting. And what that really means is it's the process of taking the operating system, the soul of the machine, from where it lives permanently on the hard drive and loading it into the computer's super-fast short-term workspace, which is the RAM.
Without this booting sequence, your computer is just an expensive paperweight. It's the process that literally breathes life into the hardware, getting it all ready for your commands. It's kind of like the digital version of that first big stretch and a cup of coffee in the morning. Okay, but before it can even think about starting its day, the very first thing your computer does is a quick checkup on itself. Just like you might take a second to see how you're feeling, the computer has to make sure all its most important parts are there and ready to work. And this is called the POST, which stands for Power On Self-Test. It's this incredibly fast diagnostic that happens in like the blink of an eye. The POST is basically the system asking itself, okay, is my brain connected? Is my memory working? Can I see anything? Can I talk to the keyboard? So during this super quick check, it's verifying all the crucial stuff. The CPU, the computer's brain, the RAM, its short-term memory, and the hard drives. It also makes sure it can actually talk to you through things like your keyboard and your monitor.
Now, if everything checks out, the post finishes up quietly and we move right along. But if it finds a problem, like maybe your memory stick is loose, it can't show an error on the screen yet, right? So instead, it speaks in code, a series of beeps. Ever heard those? Yeah, that's your computer trying to tell you exactly what's wrong.
All right, health check is done. The computer knows its body is working. Now for the main event. It has to find its consciousness. It needs to find its operating system, whether that's Windows or Mac OS or Linux. But how does it even know where to begin looking? Well, it needs a map. And that map is a tiny, tiny piece of data stored in a very specific and super important place on your drive that acts as the starting point for literally everything else. This map is called the MBR, or the Master Boot Record. Just think of it like the very first page in the instruction manual for your hard drive. It tells the computer how the drive is organized and, most importantly, where to find the next little program it needs to run to keep this whole process going. So this whole path to waking up looks something like this. It starts with the computer's most basic software, the BIOS or UEFI, which scans around for something it can boot from. Once it finds your hard drive, it reads that master boot record we just mentioned. That MBR then kicks off another tiny program called the Bootstrap Loader. And that loader has one job: find the kernel, the absolute core of the operating system, and pull it into RAM. And once that kernel's loaded in the memory, boom! The operating system finally takes the driver's seat. It starts loading everything else it needs, like drivers and your user profile, and just a few moments later, your familiar desktop pops up. The computer's brain is now officially awake and ready for action. Now, you've probably noticed that just restarting your computer is way faster than turning it on after it's been completely off. And there's a really good reason for that. It turns out they are actually two different kinds of booting. When you start up from a totally powered down state, that's a cold boot. It has to do the whole shebang, the full power on self-test, checking every single piece of hardware from scratch. But a warm boot, that's a restart, is different. The power never actually cuts from the hardware, so the system knows it can safely skip some of those initial checks, which makes the whole process a whole lot faster. So up until now, we've been talking as if a computer only has one brain, just one single operating system. But what if you wanted to have, say, both Windows and Linux on the exact same machine? Well, that adds a new step to the process, a choice. This is called dual booting. And in this case,
instead of the MBR just automatically loading one OS, it loads a special program called a boot manager first. And what the boot manager does is it pauses everything and pops up a menu, letting you choose which operating system you want to use for that session.
Really, the big difference here boils down to purpose and how complicated it is. Standard booting is simple. Its only job is to load the one OS you've got. Dual booting, on the other hand, is all about giving you a choice, and that just means you need a slightly more complex setup with that bootloader menu.
So here's the bottom line. Every single computer has to perform a boot process. It's fundamental. Dual booting, though, is an optional extra. It's an enhancement to that process that gives you a ton of flexibility if you're a user who needs different kinds of environments on the same machine.
And at the end of the day, it all comes back to this one simple, powerful idea. It doesn't matter if you have one operating system or 5, the goal is always the same. Get that OS from the hard drive into RAM so the computer can truly come to life.
And that kind of leaves us with a pretty cool thought to chew on. Today, we can choose an entire operating system when we turn on our computer. As tech keeps moving forward, what other big choices could we make right at that moment of awakening? Could we choose to boot into different work modes or different security levels, maybe even completely different ways of computing? That simple act of pressing on might just be the very beginning.